This standard is ARCH.HSA.SSE.A1.8.4a. The learning target is I can interpret expressions that represent a quantity in terms of its context. So in this tutorial, we're basically going to discuss polynomials. Polynomial expressions represent a quantity. And although a polynomial can be one number, such as the number 3, that is a quantity. However, with many polynomials, we have variables. And if a number or a value has not been assigned to the variable, then 3a could potentially be worth 6 or 6 million or negative 6 million. So basically, we're trying to understand how to identify a polynomial, not necessarily find a value for it. So if a polynomial can be one number here, or several numbers added together, such as here, where we use a variable attached to a number, or subtracted from each other, such as here. Polynomials can be one term or several. So this is one term, and one-term polynomials are called monomials. A two-term, where they're being added or subtracted, the terms are called a binomial when there are two terms. When there are three terms being added or subtracted, we call it a trinomial. The two basic rules for what would not be a polynomial is negative exponents would make it not a polynomial, and no variables in the denominator. If there's a variable in the denominator, it's not a polynomial. So if you see either of these kinds of expressions, they're not polynomials. The basic structure of a polynomial looks like a times x raised to the n, even if the n is 0 or 1. Or it's invisible. As I said, these are all polynomials. It's just showing you here that n cannot be negative, and this will never be a ratio format. The degrees are exponents. So when you see an exponent, that's the third degree, for example. The exponents are written left to right when you have binomials or trinomials, or even with 4 terms, 5 terms, 6 terms. The degrees are exponents written left to right, highest to lowest. So for example, you would see x to the 2 and then an x value term and then a constant term would be last. And in this example, if you have x to the third, you would write the polynomial in this order because x to the third is higher than x squared, which is higher value than, a higher exponent than x to the 1 and then the constant. So if you see a polynomial that is jumbled up, for example, 9 plus x plus 2x squared plus x cubed, they're basically telling you to rewrite it. Rewrite right. Rewrite it in this format, with the exponent with the highest degree starting from the left. And that's the end of this tutorial.